Welcome to the last episode of my Bevy tutorial series. Over the course of this series, we have covered all the core features of Bevy and used them practically to make a simple game. I hope you have seen how easy it is to make things with Bevy and feel inspired to try it out on your own projects. I could continue this series into just making a game, but I feel like that's against the spirit of the series, and I have achieved my goals with it. In this episode, we'll do some final tidying up and loosely explore ways to expand the game, but most of it will be left as an exercise to the viewer. Going forward, my weekly tutorials will still be Bevy-centered, but will become standalone videos covering a single topic. The first exciting thing we get to do this week is upgrade to Bevy 0.7. All our dependencies quickly updated to 0.7, so all we need to do is change their version numbers to the most recent version and run cargo update. There is one breaking change where vsync is no longer a parameter on window descriptor, and it's been replaced with a present mode. Present mode is an enum which follows the naming scheme from Vulkan, and FIFO is the equivalent of vsync in the new system. Also, we can use some of Bevy's new features like marker components on cameras, so we no longer need a main camera tag to separate between UI camera and main camera. Instead, we can query for the camera 2D marker. Another great feature is we no longer need to label functions for ordering. We can just call after and pass the system we want it to run after. This is a great update in my opinion, and it shows Bevy's focus on ergonomics. Next, let's improve the player's graphics and cover basic animations one more time. In our character sheet, we'll add 4 more arrays to hold the indices of the player walk animation frames, and we'll create components for player graphics which will hold the directions the player is facing. We add our new arrays to the resource creation, and then we'll create a new function to update the player's graphics. Here we need to query for the player's graphics and frame animation component, and we only need to run this system when the player graphics change. We just match against the facing direction, and then we'll copy the index array into the animation frames. Now when we spawn the player, instead of using our ASCII art, we can spawn a sprite sheet with the correct size and our character sheet handle. Then we insert our animation frames in the graphic component. We can also get rid of the background because it's not needed for the new graphics. Finally, in movement, we want to be able to change the character's graphic, and then if the player moves in a direction, we'll update the graphic to be facing in that direction. After all of these changes, we now have an animated player that faces the direction we are walking. One quick change I'm going to make here is to change the ordering so that the left and right sprites are prioritized over the up and down. Another cool thing we can do with Rust in Bevy is to create a function on a component. For example, let's implement leveling up for the player. We can impl player with a function to give experience. We need to mutate the player in the combat stats, and we need the experience to give. We just add the experience to the player, and if experience is greater than 50, then we'll increase the stats and remove the XP. Finally, we'll make this return true if the player just leveled up. Now in combat, we need to mutate player stats, and we can call giveXP on the player component. Finally, if the player levels up, let's create a text informing the player they leveled up. There are plenty of ways to expand this for gameplay, like adding different curves for how stats increase and requiring more experience for each level. As our final gameplay system, let's spawn random enemies for the player to encounter. First, we'll create an enum for enemy types, and we'll add that enum to our enemy tag. Then, when we spawn an enemy, we want to randomly select one of the types. Let's get the rand crate and add it to our cargo toml so we can use random numbers. Now we just get a type by matching against rand.random. If we wanted to weight the enemies to make some rarer than others, we could do that here. Then we match against the types to create the combat stats. There are obviously many different ways to make this more sophisticated and easier to work with, like we could define stats in an external text file and then load them in. We also want different graphics for different enemies, so let's add ghost frames to our character sheet resource. We could even load the description for parsing a sprite sheet from a file, which is what I'm doing in my own Bevy projects. Now we just need to change spawnBat into a generic spawn enemy function, and then we'll call that when we spawn the enemy. Finally, I changed the experience reward to be based on the enemy type. If you wanted to have multiple enemies in combat, you could sum up the reward here. There are plenty of more features we could add to this game, such as different types of NPCs, boss enemies, multiple enemies in combat, different enemies in different areas, an Undertale-style minigame for attacking, health bar graphics, and so on. But I'm choosing to leave those as exercises for the viewer. The goal of this video was to show how quickly you can add features to games with Bevy, and I think that we've covered enough Bevy in this series that you're ready to start making your own games. At this point, you should be able to confidently dig through the cheat book and Bevy examples to learn how to use any system you need to create an interesting game. Going forward, I'm still going to do weekly tutorials, but I'm going to focus more on a single one-off topic instead of a sequential style. I have plans on doing particle systems, shaders, physics, and much more, so I hope that you subscribe and follow along in the journey. As always, the link to the code for this project is in the description, along with an invite to join my Discord server to talk about Bevy, or to suggest future topics for videos. Thank you for watching.